Okay, in this video, we're going to solve this problem right here, and so let's begin. So first, if you were to plug in infinity here and infinity here, what you're going to be getting is infinity, and 1 over infinity is like 0. So you have infinity over 0. And so that's a red flag that you have to approach this problem differently. And so what I'm going to do is say that I have y is equal to x raised to 1 divided by x. So I'm not making any actual change. Instead of saying x raised to 1 over x, I'm saying I have y is equal to that. So what I'm going to do next is take the natural log of both sides. So I'll have ln y is equal to ln x raised to 1 over x. I'm going to do this in order to apply log properties, because I know that this right here is equal to 1 divided by x ln parentheses x. And so we could say we have ln y is equal to ln parentheses x divided by x. These two equivalent. So let's apply to what we actually have. So we have the limit as x approaches infinity. And I'm going to say I have ln parentheses y is equal to the limit as x approaches infinity for this piece right here. So we have ln parentheses x, close it, divided by x, close it. Now we can see something interesting. If I plug in infinity here and I plug in infinity here, what I end up getting is infinity divided by infinity. Now this allows us to use L'Hopital's rule. So now we're just going to focus on this piece and use L'Hopital's rule. So we'll have equal L'Hopital's rule. We have the limit as x approaches infinity. For parentheses, I'm taking the derivative of the numerator and I'm taking the derivative of the denominator. Now the derivative of ln x is just 1 over x. And the derivative of x is just 1. And so what we end up getting is the limit as x approaches infinity for, 1 over x divided by 1 is just 1 over x, close parentheses. Now if we plug in infinity here, we get 1 over infinity, which is approaching 0. Now we're not done yet, because we have to remember we're saying that the limit as x approaches infinity for ln y. This is very important. It's not y, it's ln y. And earlier we said y is equal to x raised to 1 over x. So that's this piece right here. But what we just found out is the limit as x approaches infinity for ln y would give us a 0. But we want to figure out for y. So let's clean this up a little bit. So what we have right here is the limit as x approaches infinity for ln parentheses y is equal to this stuff, which we just said is equal to 0. So let's write just this part right here, because we know this part is 0 and this is the same thing. So we can say we have the limit as x approaches infinity for ln parentheses y is equal to 0. But in this actual problem, what we want to find is y, because y represents x raised to 1 over x. And so what we need to do is get rid of the ln. So what we could do, let's think about this. ln parentheses y is equal to 0. If I put an e right here and I put an e right here, the e raised to ln cancels out, and we get y is equal to e raised to 0, and e raised to 0 is just 1. And so our final answer for this problem right here would be 1. So the limit as x approaches infinity for x raised to 1 divided by x would give us 1. And that's all we need to do for this problem.